Imagine a robot walking into a messy living room. Clothes on the couch, objects scattered on the floor, random items everywhere. Now imagine that robot quietly looking around, deciding what needs to be cleaned, and then organizing the entire room by itself. No remote control, no step-by-step instructions, just a robot figuring it out on its own. That's exactly what the latest demo from Figure AI appears to show. And if the technology behind it works the way the company claims, it could mark a major shift in the race to build truly useful humanoid robots. Because the robot in this video isn't just following a fixed program. It's powered by a new AI system called Helix, running inside Figure 02 and Figure 03 humanoid robot. And Helix is designed to do something robots have struggled with for decades. Combine seeing, thinking, and acting in one unified system. In the demo, the robot enters a cluttered room and begins cleaning. It picks up objects from the floor, places items back where they belong, and continues the task for several minutes without stopping. At first glance, it may look simple, but this kind of behavior is extremely difficult for robots. Most robots today are designed for very specific tasks. Pick up a box, move it to a location, repeat the same motion again and again, change the object or slightly change the environment, and the system often fails. Real homes are unpredictable. Objects are different shapes. They're placed randomly, and nothing is perfectly arranged. For a robot to operate in this kind of environment, it needs something much closer to human-like perception and decision-making. That's where Helix comes in. Helix is what researchers call a vision-language action model. In simple terms, it allows the robot to connect three abilities. First, the robot sees the world through cameras. Second, it understands context and instructions. And third, it converts that understanding into physical movement. But what makes this approach especially interesting is that Helix controls the robot's entire body at once. Instead of separate systems handling walking, arms, and hands, a single AI model coordinates everything. Every step, every arm movement, every finger adjustment, all working together. And if you watch the demo closely, you can actually see this happening. When the robot grabs an object, its fingers don't just close once. They make tiny adjustments while holding the item. Small corrections that help maintain grip and prevent the object from slipping. These micro-movements are something humans do naturally, but they're extremely difficult for robots. And they're essential if humanoid robots are going to interact safely with everyday objects. Because the real world isn't perfectly predictable. Now, the living room demo isn't the only example of what this system can do. In another recent demonstration, the same humanoid robot performs a task in a kitchen. This time, the robot unloads and reloads a dishwasher. It removes plates, picks up bowls and utensils, and places them into cabinets and drawers. Again, the important part isn't just one action. It's the long sequence of actions performed continuously. The robot completes task after task without needing to stop or reset. Researchers call this long horizon autonomy, and it's one of the biggest challenges in robotics. Because performing a single action is relatively easy, but performing dozens of actions in a row without failure is much harder. Every new movement introduces the possibility of something going wrong. An object might slip. The robot might misjudge its position, or a small mistake early in the task could break everything that follows. Yet systems like Helix are starting to show progress in exactly this area. Another key part of that progress is the robot's hands. Recently, Figure AI introduced a new 7th-generation robotic hand designed for much greater dexterity. The hand includes improved sensing and more precise finger control, which allows the robot to manipulate objects more carefully. This matters because hands are one of the hardest engineering problems in humanoid robotics. A human hand can perform thousands of subtle movements, gripping delicate objects, adjusting pressure, rotating items in the palm. Replicating that level of dexterity with machines is incredibly challenging. But without capable hands, humanoid robots can't perform most real-world tasks. And perhaps the most important development isn't happening in demo videos at all. Figure robots are now being tested in real operational environments running continuously. Inside facilities in San Jose, humanoid robots are operating around the clock, performing tasks repeatedly in controlled industrial settings. Instead of short demonstrations lasting a few minutes, the robots are expected to run for hours at a time. This step is critical because robotics history is full of impressive demos that looked amazing on video but never worked reliably in real environments. The real test of any robot isn't what it can do once. It's what it can do thousands of times without failing. And that's exactly what companies like Figure are now trying to prove. At the same time, the competition in humanoid robotics is accelerating rapidly. If you think that was crazy, hold on. Xiaomi Robotics Lab, working alongside Tsinghua University and Gust, just published research on something called HAIC. And the way I want you to think about it is simple. They gave a robot a sixth sense. Specifically, the ability to feel and understand objects it cannot see. Instead of relying on cameras, the system reads feedback from the robot's own joints in real time. It analyzes the forces, the resistances, the subtle shifts in its own body to build a model of what is happening in its blind spot. It is essentially digital muscle memory, the same intuition a human has when carrying a heavy bag in the dark. And when you see what this enables in practice, it is hard not to be floored. Blind skateboarding, 100% success rate on gliding and dismounting without ever looking at the board. Not 90%. Not most of the time. Every single attempt. Heavy load pushing. Carts weighing up to 70 kilograms, that is around 154 pounds, moved with complete stability. And it is not just raw strength. The system is actively predicting velocity and acceleration on the fly, compensating for inertia before it even becomes a problem. Obstructed navigation. The robot carries large boxes that fully block its view of the ground and still navigates stairs and slopes without a single error. And the one that matters most for the industry, generalization. Different box sizes, different weights, different load distributions, zero specific retraining. The model adapts in real time. Every environment where cameras are unreliable, which is most real-world environments, suddenly becomes navigable. Multiple companies are racing to build machines that can work in factories, warehouses, and eventually everyday environments. But the real battle may not be about the robots themselves. It may be about the AI systems controlling them. Because once a powerful robotic intelligence exists, it could potentially operate many different robot designs. In other words, the most valuable technology might not be the hardware, but the AI brain behind it. If systems like Helix continue to improve, we may be approaching a moment where humanoid robots finally move beyond laboratories and into the real world, cleaning homes, working in factories, helping people with everyday tasks. For decades, this idea felt like science fiction. But now, step by step, it's starting to look possible. And the next few years may determine which companies lead the future of humanoid robotics. If you want to stay ahead of every humanoid robot breakthrough, subscribe to RoboFrontier.